Everyone, let's continue our topic now. Jaswinder, Satinder, Semos.
Yeah.
So our pending top. Okay, any question from previous sessions, everyone? Previous topic. Satinder, any question from previous topic? Semos, any question?
No.
No, right now, no.
Okay, now. So our pending topics are, everyone, our pending topics are decryption policy configuration. See, decryption policy configuration, wildfire discussion, global protect, and monitoring and reporting. So these topics are pending. Okay, before start this topic, let's talk about packet flow concept. Jaswinder, let's talk about Palo Alto Firewall packet
Yeah.
flow concept in detail. Okay, wait. So what is packet flow concept? In packet flow, we can discuss how traffic is traveling through Palo Alto Firewall. How traffic is traveling. If you guys remember our day one or day two session, remember our basic packet flow discussion? Basic packet flow discussion, everyone. Basic packet flow discussion. For example, I have Palo Alto Firewall. Okay, here I have Palo Alto Firewall. This firewall is connected with LAN side network. So here we have a switch, computers. This side is your public facing network, ISP portion, you can say. Okay, inside machine IP address is 192.168.10.10. So we are trying to focus on packet flow in Palo Alto file. So when this, my point is, when this 10.10 is trying to communicate with this 8.8.8. So when traffic will hit on Palo Alto firewall ingress interface, when traffic will hit on Palo Alto firewall ingress interface, then firewall will do initial packet processing first. Firewall will do initial packet processing first. And in initial packet processing, firewall will check source zone information. Firewall will check source zone, source IP address, okay, source user information, source zone, source address, source user. So this 10.10, as per our task, this 10.10 is trying to communicate with this 8.8.8. So this traffic will hit on firewall device. This interface is a part of LAN zone, and this interface is a part of WAN zone as per our configuration. So when traffic will hit on ingress interface, firewall will do initial packet processing. It will check source zone. So as per our task, our source zone is a LAN zone. What about source address? 192.168.10.10. Source user, for example, this is user number 1. So firewall will check source zone, source address, and source user. After that, firewall will check what? Okay, you want to communicate with this 8.8.8. So firewall will check forwarding lookup, or firewall will check PBF, policy-based forwarding. Policy-based forwarding or forwarding lookup, or you can say routing table. Firewall will check routing table. Is there any entry available to reach this particular destination 8.8.8? So in your scenario, you have a default route. Okay, let's take example. You have a default route towards ISP. So based on your routing table, firewall can identify your exit interface. Firewall can identify exit interface based on routing table. So now this fast Ethernet 0/1, it's an exit interface to reach this 8.8.8. This interface, it's a part of WAN zone. So based on your forwarding lookup, Firewall will check destination zone. Firewall can identify destination zone. This interface is active interface and this interface is a part of WAN zone. So this time firewall has source zone and destination zone information. Clear my point? Simos, Jaswinder, Satinder,
Yes,
everyone.
Yes, sir.
Now, as per your configuration, as per your task, now traffic is traveling, okay? Traffic is traveling now. Traffic is traveling and traffic is traveling from source zone LAN to destination zone WAN. So traffic is traveling from one zone to another zone. So firewall will check NAT. Here firewall will check NAT option, NAT policy evaluated. It will check NAT. Is there any NAT entry available for this source zone and destination zone in between this source zone and destination zone? So if you guys remember our NAT concept, so we have two type of NAT, right, everyone? Source NAT and destination NAT. Source NAT and destination NAT. If you guys remember source NAT configuration, so in source NAT, source zone is a LAN zone and destination zone is a WAN zone. But in DNAT, everyone, remember, source zone is a WAN zone and destination zone is a WAN zone, right? Remember DNAT configuration, just remember Satinder, Simos. So if traffic is initiated from same zone, for example, if traffic is initiated from WAN zone, it will hit on same zone, it's a DNAT. So based on your zone information, firewall can identify, okay? Firewall can identify it's a source NAT or the destination NAT is required for this traffic. So in your scenario, traffic is traveling from LAN to WAN. Traffic is traveling from one zone to another zone. So firewall will check source NAT. Firewall will check source NAT. Is there any source NAT entry available? Now firewall will go for security pre-policy. So before discuss this security pre-policy, let's discuss this scenario, only this scenario in detail. Okay, Jaswinder, only this scenario in detail. Okay. So now this is a actual packet flow concept in Palo Alto Firewall, everyone. When firewall will receive any packet, it will extract L2 information, MAC address, IP address, and L4, service or protocol. So when traffic will hit on ingress interface, firewall will extract L2, L3, and L4 information. After that, if there is any error, onto this ingress interface, just with that, maybe this interface is down, maybe some issue with interface, okay? So if any problem with ingress interface, ingress interface process error, if there's any error, packet is discard. But if interface is working fine, so firewall will go for inspection. So firewall inspection is applicable for this traffic. Now, traffic is going to hit here on firewall device. Now, firewall will check this traffic is a part of slow path or it's a part of fast path. So firewall will check this traffic, this complete traffic is a part of slow path or fast path. So how firewall will identify slow path or fast path? So firewall will check 6 tuple information. Firewall will check how firewall can identify. Firewall will check 6 tuple information. My point is when traffic will hit on ingress interface, firewall will extract L2, L3, and L4 information. Now, if entry is available in session table, remember I told you firewall is a Palo Alto firewall is a stateful firewall device, right? And if traffic is traveling through the appliance, firewall will maintain the state of connection in connection table, in state table, right? So if this traffic is a part of any existing connection, if this traffic is a part of any existing connection, on existing connection, traffic is traveling. How firewall can identify this traffic is a part of existing connection behalf of 6-tuple information? Firewall will check source IP, destination IP, source port number, destination port number, protocol, and zone. So based on 6-tuple information, firewall can check, okay, this is not a new packet. This is not a new traffic, okay? On existing session, traffic is traffic. So it's a part of fast path. Clear my point? Jaswinder, Satinder, Simos. Our task is related with slow path. Okay, because we are talking about new packet. Everyone clear my point? Jaswinder, Satinder, Simos.
Yes.
Simos, our task is related with slow path. So now if traffic is traffic, okay, if this traffic is not part of any connection, any existing connection, if 6-tuple information is not available in database in session table, so if session match not found, not found, so firewall will go for slow path. Slow path. Now slow path, wait. In slow path, wait. In slow path, okay, let's discuss here. In slow path, I have a Palo Alto firewall. Palo Alto firewall. This is interface. Fast Ethernet, for example, 0/0. Fast Ethernet 0/1. Everyone, please wait 1 minute. Jaswinder.
Yeah, sure.
Everyone, can you hear me? Jaswinder, Satinder, Simos.
Yes.
Okay, let's continue our topic now. Okay, so I have a Palo Alto firewall device. Okay, and here we have fast Ethernet 0/0 interface, fast Ethernet 0/1. So now the point is, we are talking about egress interface. See, if traffic is going to hit on firewall device, and if this traffic is a new traffic, it's a brand new traffic. Okay, it's not part of any existing connection. So when traffic will hit on interface, my point is when traffic will hit on interface, in initial packet processing, firewall can check source zone, source address, source user. Yes. Now the next task is what? To find egress interface. And to find egress interface, we are using forwarding lookup or routing table. But this is not an easy task, okay? In case, if this interface, everyone, if this interface is a tap interface, then Jaswinder, remember our interface type configuration in Palo Alto, Satinder?
Yeah.
Yeah.
In Palo Alto interface type, we have L2, L3, tap, virtual wire, layer 3. So in case, if this interface is a tap interface. So remember I told you tap interface we are using for monitoring. Tap interface we are using for monitoring. So if this interface is a tap interface, so this interface is a ingress interface and same interface is a egress interface. So packet will drop here. Clear my point? Packet will drop here if this interface is a tap interface. In case if this interface is a virtual wire, what is virtual wire? Let's talk about virtual wire first. Okay, wait. So virtual wire is like a layer 2 firewall implementation in Palo Alto firewall. Okay, layer 2 firewall. If we talk about Fortinet, so we can use our complete box as a layer 2 firewall, right, Simos? Complete box, Jaswinder. We can use our box as a layer 3 or we can use as a layer 2, complete box.
Yes.
But in Palo Alto, you can use your interfaces. In Palo Alto, we cannot use our complete box as a layer 2 firewall. No. In Palo Alto, we can use our interfaces as a virtual wire interface. Virtual wire interface is like a layer 2 firewall implementation. Remember our layer 2 firewall implementation discussion? Layer 2 firewall we can use. Layer 2 firewall we can use. For example, I have an existing routing switching topology. Okay, this portion. Here we have a switch, multiple computers. Okay, I have an existing routing and switching topology. Everything is working fine. Into this topology, I want to deploy a firewall device. So this portion, if you want, this portion is a single subnet, LAN portion, and this portion is a WAN subnet. Into this existing scenario, if I want to deploy a firewall device, in case if I'm using this box as a layer 3 firewall device, in case if I'm using this complete box as a layer 3 firewall box, so these interfaces are L3 interfaces. If these interfaces are L3 interface, it means each interface will participate in different subnet. So you need to change your existing IP address scheme into this scenario. If you are using your box, your next generation firewall box as a layer 3 firewall box into this existing scenario. Now your single subnet, my point is your single subnet is divided into two different subnets, different network, right? In case if I don't want to change anything in my existing scenario, I don't want to change anything, and I want to deploy a complete next generation firewall device. I don't want to change any IP address scheme. I want to deploy here a next generation firewall, so I can go with layer 2 firewall. This firewall is a layer 2 firewall device, so these interfaces are what? Layer 2 interfaces. Okay, it's not a switch port, it's a layer 2 interfaces. It's not a switch port, it's a layer 2 interface. No need to configure IP address on any interfaces, but yes, you can give a name. For example, this is LAN interface. This one is a WAN interface. And again, you have a single subnet. It's a firewall. So to allow your traffic from one zone to another zone, yes, you can create a policy. And you can create a policy. So layer 2 firewall we can use in network where you don't want to change any IP address scheme and you want to deploy a complete next generation firewall. FORTINET, yes, you can do this, but in Palo Alto, scenario change. In Palo Alto, there is no concept of layer 2. In Palo Alto, we have vWire concept. vWire concept. So I have a Palo Alto firewall device. These two interfaces, everyone, these two interfaces I'm using as a virtual wire interface. I cannot use complete box as a layer 2 firewall box. Only two interfaces I want to use as a layer 2 firewall kind of implementation. So I can go with virtual wire. If this interface is a virtual wire, so you cannot configure IP address on virtual wire interface. Wait, let me show you. Wait. Okay, Jaswinder, Satinder, Palo Alto Firewall will take time. Simos. So now what we can do here, we can use virtual wire concept. So these interfaces are what? These interfaces are L2 interfaces. Okay, you can give a name. For example, this is LAN interface. This is WAN interface. It's a zone-based firewall device. So if you want to allow your traffic from one zone to another zone, you can create security policy. Other interfaces, everyone, other interface. For example, I have multiple interfaces on Palo Alto firewall device. So yes, these interfaces I can use as a L3, interfaces. So this is the difference, everyone. If you compare with Fortinet, you can use the complete box as a layer 2 firewall box. Why Palo Alto is popular option? Because in Palo Alto, you can use your one or two or three or four interfaces, okay? Interfaces you can use as a layer 2 interfaces. Clear my point? No need to use your complete box as a layer 2 firewall device, no? Satinder, clear? Simos?
Yes.
This concept is called virtual wire pairing concept. Virtual wire pairing, okay? Virtual wire pairing. So in pairing option, what we can do, virtual wire pairing, what we can do, we can pair two interfaces. We can pair two interfaces. These two interfaces we can pair. So whenever traffic will hit on this interface, this okay, whenever traffic will hit on this interface, his exit interface is always 0/1, always. So firewall will not check his routing table or other information. No. As per virtual wire pairing configuration, if traffic will hit on this 0/0, his peer interface is 0/1. So his exit interface is always 0/1. When traffic will hit here, exit interface is 0/1. I hope this option is clear, Jaswinder, for you. Simos?
Yes.
Simos?
Yes, yes.
Now let's try to implement this. Okay, wait. Let's try to implement. Okay, wait. So this Palo Alto will take time. So this is what? Virtual wire deployment. vWire deployment. vWire deployment. Okay, so let's configure this router first. Palo Alto will take time. So this portion, into this topology, this router is a public facing router. This is public facing router. And this portion is a LAN portion. This portion is a LAN portion. And these two interfaces I'm using as a vWire interfaces. So we have what? Same subnet in LAN side network. Same subnet. Now IP address, interface Ethernet 0/1, IP address 200.1.255.255.255.0, no shutdown. You can verify IP address configuration. See, this is public facing interface. So we are getting IP address through DSCP. Ethernet 0/1, it's a LAN interface. We have a default route, show IP route. We have a default route towards this ISP gateway. So you can check your internet connectivity. Internet connectivity. I have internet connectivity, okay? Now let's go on firewall device. Firewall will take, okay, let's check. Let's try to log in here. Okay, this will take time. Let's go on LAN machine. We can check IP address configuration. So same series of IP address I'm using 200.200.200.20 gateway and DNS entry. Let's verify management IP address. .199.199.199.20. Okay, let's take a break for 5 minutes. Okay, this Palo Alto Firewall will take time. Let's take a break for 5 minutes, Jaswinder only. Satinder, Simos.
Yeah, sure.
Yes, sure.
Okay, we can continue at 8:40. Okay, please turn off your mic. Everyone, can you hear me? Jaswinder, Satinder, Simos.
Yes.
Okay, let's continue our topic now, everyone. IP address is 199. Okay, let's go on. Let's access this file. Satinder, can you hear me?
Yes.
Simos.
Yes, yes.
Okay. Okay, so as per our topology, these two interfaces we are using as a virtual wire interface. So you can go to network tab, interface. So Ethernet 1/1. It's a V-wire interface. So I'm not using as a L3 interface, it's a V-wire. V-wire. So, but you can see, you can verify if this interface type is L3. Okay, so yes, you can configure IP address, IP version 4 and IP version 6. Okay, if I'm using this interface as a V-wire interface, so you cannot configure IP address. So I hope this point is clear. You cannot configure IP address on virtual wire interface. It's a layer 2 interface. It's not a switch port. It's a layer 2 interface. You cannot configure IP address. So you can put this interface in virtual wire. This concept is called virtual wire pairing. Okay. So you can create virtual wire from here. For example, I'm creating V wire 1 1. Otherwise, you can create. Okay. Let's select only interface type virtual wire. You can click on okay. Interface type virtual wire. This interface 1/2. Yes, I want to use as a virtual wire interface. Now you can go to virtual wire. Okay, let's commit this configuration first. Wait. Wait, I think I was using these interfaces and policy. Please wait, everyone. NAT is not required. Policy is not required. Let's commit our configuration now. Okay, so interface type, Jaswinder, Satinder, Simos, interface type, I'm using virtual wire for both interfaces. Now you can go to virtual wire. We can create virtual wire here. I'm giving a name, for example, V wire 1 1. And you can see we have only two interface options, interface 1 and interface 2. That's why this concept is called virtual wire pairing. We can add only two interfaces. So yes, I have two interface type, Ethernet 1/1, it's a virtual wire interface type. Interface 1/2, it's a virtual wire interface. You can click on OK. You can commit your configuration. Now let's go on interface, network interface. So this interface is a virtual wire interface. And I'm using this interface as a LAN interface. So LAN zone, let's create a zone here. LAN-zone. You can click on OK. Click on OK. Now Ethernet 1/2 interface. WAN zone. We can create WAN zone, WAN-zone. You can click on OK. Click on OK. Now to allow our traffic, from one zone to another zone, yes, we need to create policy. Translation is not required in between these two interfaces. Jaswinder, Satinder, Simos. Translation is not required, okay, because here we have LAN portion, right? This portion is what? LAN portion. What we are doing, if traffic is going to hit on LAN zone and trying to travel to WAN zone, yes, we are trying to allow, so we can create security policy rule. Security policy rule. vwire -policy1. Just a policy name. Interzone communication. Source zone is what? LAN zone. And destination zone is what? WAN zone. Any source address, any destination address, any application, any service URL category action is allowed. Log at session start, you can click on OK. Before commit this configuration, let's go on LAN machine, everyone. Let's go on LAN machine. If I'm trying to ping my gateway, directly connected gateway, 200.200.1. Remember, everyone, we are using 200.200.1 on router interface Ethernet 0/1. See, this is LAN portion, right? LAN portion. We are using same series of IP. 200.200.20, and here we have 200.200.200.1. So I'm trying to ping same series of IP address, but I'm not getting reply. Because in between this LAN machine, this gateway, we have a firewall device, zone-based firewall. So to allow our traffic, we can create policy. Let's commit our configuration now. Okay, before commit, okay, wait. Let's initiate other traffic. I'm trying to ping 8.8.8, for example. 8.8.8. You can see on router, this router is a public facing router. Okay, I can ping Google DNS. I'm getting reply, but this inside machine cannot communicate with 8.8.8. Let's create our policy. Let's commit our configuration. We have a policy. Everyone can hear me? Jaswinder, Satinder, Simos. I am not
Yes.
getting reply. Okay, let me check. Okay, please wait. I'm not getting reply. So Ethernet 1/1. Let's ping gateway first. Now I can ping gateway. Okay. I'm not getting reply. Why? Because this router is a public facing router, and to allow our traffic, we need translation, right, everyone? Translation. This is public facing router, and traffic is trying to travel from private to public side. Jaswinder, Satinder, clear my point?
Yes.
NAT is required onto this router. Let's create NAT. Remember Cisco router configuration? So wait, IP NAT, IP, IP NAT inside source list, ACL number, source list, interface, and interface is Ethernet 0/0 overload command. If you guys remember, this is PAT configuration on Cisco router. Now we can create access list. Access list 10 permit any source, and now you can apply your NAT. Ethernet 0/1 is a LAN facing interface, so IP NAT inside, and interface Ethernet 0/0 is a public facing interface, so IP NAT outside. And now we can check IP NAT outside. Now wait. See, I'm getting reply. Jaswinder,
Yes.
this is what? vWire complete deployment. So now you can see you can ping 8.8.8 CMOS. You can access google.com, facebook.com. You can ping and you can access google.com. I hope this topic is clear. Satinder, for you, Jaswinder, Simos.
Yes.
Okay,
Yeah.
let's move on. Packet flow concept. So our topic, let's see. So now here we have, see, I have a Palo Alto firewall device. Palo Alto firewall device. Wait. Palo Alto firewall. This portion is fast Ethernet 0/0. And this one is fast Ethernet 0/1 interface. Now, when traffic will hit, my point is when traffic will hit on this interface, firewall can check source zone, source address, source user. Now, firewall is trying to find egress interface, trying to find egress interface for destination zone. And to find egress interface, firewall will check forwarding lookup, or you can say routing table. So now when traffic will hit, if this interface is a tap interface, this interface is a tap interface. So same interface is an ingress interface. Okay, this interface is ingress interface and same interface as an egress interface. You can verify now if I'm using any interface as a tap interface. Wait. For example, this 1/4 interface, I want to use as a tap interface. See, tap interface. You can only assign zone here. That's it. You cannot configure IP address on tap interface. That's it. So if this interface is a tap interface, ingress and egress interface is same. So packet drop here. Packet is not traveling to any other interface. Now, in case if this interface is a vWire, now I hope vWire concept is clear. In vWire, we have vWire pairing, right? We have vWire pairing concept. So this interface, for example, if this interface is a vWire interface, for example, vWire name is vWire11. So in vWire concept, we have vWire pairing, right? So firewall can find, okay, this interface is a vWire, interface type is vWire. Firewall will find egress interface as per peer interface configured in vWire. So this interface, for example, this interface is a part of same vWire. So firewall can identify egress interface. Clear everyone? How firewall will identify egress interface? How firewall will identify egress interface? Now, in case if this interface is a Layer 2 interface, everyone. Switch port. Switch port. For example, this interface is a switch port. So now how firewall will identify egress interface? Based on MAC table. Remember, switch is taking forwarding decision based on MAC table. So firewall can identify egress interface based on MAC table. If this interface is a layer 3 interface, so how to find egress interface? Based on routing table. Based on routing table. Okay, you have a default route towards ISP side, default route towards ISP side. So this interface is exit interface as per your routing table. And this interface is a part of WAN zone. So first firewall will find egress interface, or you can say egress zone, egress interface or egress zone, you can say. So based on routing table, firewall can identify. Clear now? So now this is not a simple task, okay? It's not a simple task, okay? If based on your routing table, firewall will find destination zone immediately, okay? It's depend upon interface type. I hope this point is clear. It's based on interface type. Everyone clear now?
Yes.
Okay, so again, we have a Palo Alto firewall device, switch, computers. This side is what? It's a ISP side portion. Now, so initial packet processing, firewall will check source zone. So source zone is a LAN zone. Destination zone is a WAN zone. Based on traffic flow, firewall can check NAT. Now, next step is what? Security pre-policy. In security pre-policy, firewall will check allow ports. If there's any port is allowed. Now traffic is trying to travel. If traffic is trying to travel, firewall will create this session. Firewall will create this session. After that, within a session, inside machine is trying to access application, for example. So firewall next step is what? To detect application. So firewall will check encrypted traffic. If this complete session is HTTPS session, then firewall will check encrypted traffic. If traffic is encrypted, so firewall is looking for decryption policy. We can create decryption policy to decrypt our HTTPS connection. So firewall will check decryption policy. If decryption policy is available, firewall will decrypt this HTTPS connection. After that, firewall can identify application. So remember always, firewall will check. Palo Alto firewall will check application first. Jaswinder. Application first. For example, in URL, I'm using www.facebook.com. It's a deny. Okay, deny. But in application, Facebook is allowed. So firewall will check app ID first. Satinder, clear my point? Simos? As per your URL filtering, www.facebook.com is a block. As per your app ID configuration, Facebook is allowed. So firewall will check app ID first. Clear my point? Satinder,
Yes.
Simos?
Yes.
So now firewall will check app ID. If you guys remember your policy configuration, let me show you policy configuration step C. If I'm trying to create a policy, so first you can define, first you can define your source zone. First you can define your source zone, then destination zone, and then next tab is what? Next tab is what? Application. Application, then services, URL category, and then action is allowed. So firewall will check when application detect. When application detect, firewall will check security policy. As per security policy, if traffic is denied, for example, then traffic is denied. And if traffic is allowed, if traffic is traveling through the firewall device, then firewall can utilize security profile. Remember our security profile discussion, antivirus profile, file blocking, vulnerabilities protection, anti-spyware profile, URL filtering, everyone. So as per your security policy, if traffic is allowed, then firewall will check security profile. Now firewall will re-encrypt the traffic. First it will decrypt, then it will re-encrypt the traffic, apply the NAT. So as per your task, traffic is traveling from LAN to WAN side. Yes, we have a source NAT apply, and traffic is forward to the egress interface. Packet is forwarded. I hope this packet flow concept is clear. This is our topic. Clear?
Yes.
Jaswinder, Satinder, Simos.
Yes.
This is our topic. Packet flow concept. Now we can focus on decryption policy. Okay, let's start this topic in next session, everyone. Okay.
Yeah.
Jaswinder,
Yeah.
Satinder,
No problem.
Simos. And please connect on next weekend at same time, everyone.
Sure.
We have 4
Sure.
sessions. Okay. It's required only 4 sessions to finish our training. 11, 12, 18, and 19. 4 sessions. We can finish our training. Decryption
Nice.
policy, wildfire, remote access, and monitoring and reporting. Okay, everyone.
Yep.
Bye,
Thank you.
guys. Take care. Good night, everyone.
Bye.
Bye.
Bye, everyone. Bye.